Hello students, this is Mrs. Cindy here, and I would like to talk to you a little bit about matter in our chemistry unit. So this is chapter 1 of the chemistry unit, and we're going to just cover 1.1 in this video today. So section 1.1 is known as describing matter, okay, describing matter. So go ahead and put that as the heading of your notes. We're going to discuss some of it in class, but the bulk of the notes, please put in your binder, and there may be some places that I'm asking you to just leave blank, and we'll talk about it in class, okay? So number one, let's put chemistry a little bit in perspective. I know last year you covered kind of parts of the body, right? Organs. You covered the human body. You covered cells, I know, so you got to the cell level, and what makes up cells, molecules. I know you talked a little bit about DNA. DNA, each one of these little things, this is just one little piece of a DNA strand, and then each one of these little balls here in this DNA molecule is an atom. Okay, so here's a molecule. DNA is a huge molecule, huge molecule, right? And that just is in this tiny nucleus here. But DNA is enormous and has, I think, hundreds of millions of atoms within it, if not billions and trillions. I'm not entirely sure, but pretty unfathomable amount of atoms. Okay, so so here's us. And then you get down to the system level, digestive system, you get to the organ level, and then you got to the tissue level, you got to the cell level, and now we're talking about the molecule and atom level, and that's what chemistry is. So chemistry is the study of atoms and how atoms interact with each other to form molecules, to just change their states, any of those things. So that is the definition of chemistry. In general, you have experienced your whole life a whole bunch of chemical reactions. The different fireworks, all the different colors, have to do with what are the elements, the types of atoms that are within each of those firework containers. Rusty nails, wood, bananas, the gas that the bananas give off to make them ripen and get all brown. I have your eye here because it's made out of proteins. It has a whole bunch of liquid on it. Your whole body is made out of atoms. Honey, you know, it's sugars. It's just remarkable. Water, sugar. So everything that you have ever experienced, kind of everything you breathe in, it's all chemistry, and that's why chemistry is, you know, a required class in high school. It really is the foundation of all the other sciences. Okay, so how does it work? This is something that we'll be doing in class, those two. So in general, what are chemicals? Chemicals tend to have a bad name. They have a bad rap. That word, when you hear, oh, that's a chemical, that you know, everything is a chemical. Any substance, okay, is any substance that you can think of, any substance, anything that has, you know, mass, liquid, anything, is made up of elements. And elements are kind of those atoms. We can use, for right now, we can use elements and atoms. The little, you know, not even that ball right there. That's not even an atom. There's molecules within those. The cell wall, let's say, sorry, I'm touching the screen. The cell wall is made up of a whole bunch of different atoms. Okay, so really anything that has substance can be considered a chemical. So there are some nasty chemicals out there, some cleaning agents, some gases that are dangerous if we were to breathe them in. There are some very bad chemicals, and we tend to use that word like, ooh, that chemical, but all foods are chemicals. Water is a chemical. Okay, so any solid, liquid, or gas, any substance, and gas right there is a chemical. So anyways, organisms are composed of matter. Okay, so really anything is composed of matter, but to bring it back to kind of our hierarchy of organization, we would talk about matter. But matter is anything that takes up space and has mass. And so, of course, a rock has matter, right? And you know that. It's taking up space. It has mass. You can feel that it has something in it. Also, a liquid, orange juice, clearly is made up of atoms and molecules, right? The only one that's kind of questionable is a gas, right? And so all of these balloons are filled with a gas. When you take a breath in, filled with the gas, you know, you're putting air into your lungs. Those are examples of matter. And so let me prove, and we'll do this in class, but if you could just write this down so we can plug it right in. Let me prove that gas is indeed matter. Okay, so this is the information that I'd like you to plug in. So is gas matter? That is our question. Now that we're in the science fair, it's always good to start a little bit of an experiment with a question. And then we'll make observations, we'll take masses, we'll look at any change in mass, and then we'll answer the question. Okay, so that's what I want you to record. So one thing that I want to kind of touch upon is properties. Okay, so these properties right here, I want to talk to you a little bit about. Okay, so water is amazing, and I was just trying to think of cool places where we see water, and frankly, I Google searched cool fish tanks, and I saw these. I gotta say, that is awesome. Brushing your teeth on a fish tank. I just can't imagine cleaning that. That's why I personally haven't invested in something like this. But water is a liquid at room temperature, right? We know that. We know that it's clear when we are looking at it. We know that it turns into snow when it gets cold. We know that it can turn to ice when it's liquid, and then all of a sudden the temperature drops and we have ice cubes. We know that it can boil. We know that we can put pasta in it and cook it. All of these things are properties of water. And that's kind of what we're gearing up to look at right now. So let's move on to the actual properties. There are physical properties that we can use to describe matter and kind of to figure out what it is. If you had something on the table and it looked like water, what are the characteristics that you would use to determine that it is definitely water and not some dangerous chemical, right, on the table? So you can identify substances using both physical properties or chemical properties. And what's interesting is physical properties, okay, they can be observed without changing that chemical into another substance. So if we were to add, let's say that it's that clear glass of whatever, some clear liquid, okay, so a glass of a clear liquid, we don't know what it is. We could add maybe a piece of sodium metal, let's say, or copper metal or something like that. We could add it to the liquid and see if it reacts. But if it reacts, that means that it's turning into something different. So if it's not water, whatever it was, and it reacted with the sodium, water would react with the sodium, but if it reacted with the copper, you would be able to know that, wow, it's not water. If you put a penny into the clear liquid and all of a sudden it reacted and started boiling or whatever it was, you would realize, oh my God, that's not water, that's something else. But then also you would kind of change it into something else. You'd be having it undergo a chemical reaction. So a chemical property is a substance's ability to change into different substances. So this is really cool, and that's why everybody loves chemistry, is the chemical properties, right? We react things, we change them into different substances, and often that requires a little explosion, it requires some cool color change, it requires something. So these are the cool things, right? Chemical properties, how does it react? How does it change into a different substance? But the physical properties are really what we like to use in order to figure out what the substance is. So let's give some examples of the of physical properties, and these are all the ones. There's a lot. I'm going to give you 10. These are all the ones that I'd like you to know, and some of them are really logical. So what is its melting point? Okay, that is one physical property I'd like you to know. Meaning a melting point is at what temperature, if it was a piece of ice or if it was solid, how much do I have to heat it up in order to turn it into a liquid? Melting point is the exact same temperature as the freezing point. So just so at what temperature will the liquid turn into a solid? And for water, 0 degrees Celsius. But there's no other chemical in the world that turns into a solid or melts at 0 degrees Celsius, right? So it's unique to water, and so that would be one way that we could test whether or not that clear liquid is. On the other side, the boiling point is another example of a physical property. Number 3, and something we'll talk about in section 1.4, I think, the density So I'm just going to put it in our list. That's so we don't have to add it later. The fourth one, I would say, we'll go through some examples right now, right after we make this list, but whether or not the substance is a gas, liquid, or solid at room temperature. So what is the state, the physical state? And so I'm previewing you a little bit, which is gas, solid, or liquid. And again, if you can't recognize that G represents gas, please write it out at room temperature. Okay, so if it's a liquid at room temperature, then we know something about it, right? If it's a solid at room temperature, that tells us something about it. That has to do a little bit with the boiling point and freezing point, but physical properties can be really observational, so we can break it down into a little bit more. Whether or not as a solid, it conducts electricity. Electricity or heat. Meaning that if I have like a pan, if you start heating a pan like so if you have like a big chunk of something that looks like metal and you put it on the stove or you put it in the oven and you touch one side of it, even though it's only being heated from the bottom, if you touch the top of it and it's really hot after you've been heating it for a couple minutes, if it's hot, then that indicates that yes, it does conduct heat because it can move the heat from the bottom to the top. Or if you use a conductivity tester, or if you put it on an electric fence, if you get zapped and one end is on the electric fence and you're here, then that means that it conducts electricity. And the anything that conducts electricity or heat is known as a metal. Okay, so that really narrows it down for you. So that's 5. Sorry, we're staying on this, and sorry it's so messy, but number 6, we would say whether or not it has shine, whether or not it's shiny. We could use color as another kind of, sometimes it's dyed, so it doesn't, it's like you've added food coloring or something. It would still be water if you add food coloring to it, but sometimes color indicates what the substance is, not all the time. 8, the texture, whether or not it's smooth, and again, it's not definite that it's something, because it could be, wood, and you could have wood that you just cut just a moment ago, or wood that you've sanded down, so that wouldn't be super helpful. Number 9, color, hardness, whether or not it's hard as a metal or if it's soft. So a lot of these are solid tests. And then, what's the other one? Flexibility, if you can bend it. It's okay. We'll give you some other vocabulary words in the future. But these are kind of the top 10. I'm sure you can list a couple more, and I would probably say, yeah, that's probably a physical property. But these are kind of the top 10 that pop to mind that would be helpful for you as we move forward in the text. Okay, so now that you have those, let's do a couple of examples. Oops, I'm realizing that you can't see this. So let's go ahead and look at this. So 2 physical properties of metals are luster or shine, and the ability to conduct current, electrical current or heat, which we said. Another physical property is flexibility. Okay, so sometimes metals can be bent. It's called malleability. Okay, so what are the objects that are flexible? Aluminum can you bend that? Yes, you can. Copper sheeting, that's the stuff that's on like the roof, if you see that cool coppery color. So it's definitely, if you were to put it on, it's kind of bendable depending on how thin it is. A copper, penny is not bendable, but copper sheeting would be. A brick house, no. A glass window, absolutely not. You would not want to bend that. A silver spoon, yeah, you can bend spoons. And then a wood drumstick, you would probably snap it, so that wouldn't work. What do all of the flexible objects have in common? If you notice, silver is a metal, copper is a metal, and aluminum is a metal. A brick is not, glass is not, and wood is not. So what do all the flexible objects have in common? They're all metals. And then what's the physical property that makes metal pots good for cooking? Their ability to conduct. So they are conductors of heat. Electricity doesn't help too much in this case for cooking, but that could be another question. So that's one. Thing. This is in your book, and I'm just running through these examples because I think that they're nice to work with the material you're learning now. Wax in a burning candle can be described by both physical and chemical properties. What are the physical properties of wax in a burning candle? So you've hit the melting point, I would say. Because it's melting. And that's really, I'm sure you can think of some. I can't think of some because I'm on the spot, but melting point's a good one. Why is melting a physical property of wax? I gotta say this one's kind of cool because it's melting, right? It's coming off the candle, but it's not reacting. It's not changing. You can take that wax and re-put it back into a candle again, which I think is nice. Flammability is a chemical property because if you were to catch it on fire, then you would change it into another substance. So there you go. Melting, because you aren't changing the substance. So why is melting a physical property? Because you are not changing the substance. Flammability, you are changing the substance. You're turning it into something else. Rusty metal chain. So rust is another example of a chemical property. What happens is the metal reacts with oxygen that's just in the air, and so it rusts. Okay, we will see you on the flip side, and we'll start talking about classifying matter. Whoa, whoa, whoa.